Good day, ladies and germs. Welcome to another lesson of Matric Corona Maths. And today we're going to do a bit of trig. And I think we should start with a bit of grade 11 trig revision. Okay? Because some of your basics aren't that great. So just a little reminder of what trig is. And trig is really just ratios. And really what trig is saying that the ratios of particular sides or coordinates stay fixed when the angle is fixed. Okay, that the ratios will stay the same. So for example, if I took this angle on the Cartesian plane, so we're working on the Cartesian plane today, this is x, this is y, your angle is 30 degrees, okay, then if I've got a radius equal to 2, my angle is 32, my radius is 2, the x coordinate would be root 3, and the y coordinate would be 1. Things are happening in the kitchen, but it's perfectly fine. Right, so x is equal to root 3, and y is equal to 1. So, I want you to think about it, just use a bit of common sense, to show that you actually can do trig even if you haven't heard of trig language. If that radius is 4, okay, so if you've doubled the radius, okay, so when the radius was 2, that was root 3, that was 1. If the radius is now 4, go fill in what the x and the y coordinate will be, because the angle stayed fixed. And let's say it's obviously not to scale. If the radius was 200, okay, what would the x and the y coordinate be? Right, so go do that. Go think about that. You don't have to use trig, just think of ratios. Common sense. So what have you done to get from here to here? You've doubled your radius, right? So there you must double your x coordinate. So root 3 times 2 is going to be 2 root 3. Make it a bit bigger. So your x coordinate now will be 2 root 3. And your y coordinate, you're also going to have to double. So the y coordinate will become 2, right? Then if we start with the original one, okay, and we start with a radius of 2, I increase the radius by a ratio of 100. So I'm timesing by 100 to get to this point. So these coordinates, I must also multiply by 100. So this was root 3. So this will become 100 root 3 times it by 100. Okay, this was 1. So this will become 100. Right. So that pretty much is what trig's about. It's just saying that if the angle stays fixed, your ratio stays fixed. So, instead of every single time, say, for 30 degrees, so if I keep an angle fixed of 30 degrees, for 30 degrees, what is the ratio of the y coordinate over the radius anywhere along that line? Instead of writing that sentence down every single time, the ratio of the y coordinate over the radius at 30 degrees is going to be, to take you forever to do math, they were given names. And the ratio of the y coordinate to the radius, okay, is called sine. So sine of 30 degrees will be equal to the y coordinate here, which would be 1 over 2, okay, y over r. But I wouldn't have to use just that point. I could use any point on this line, and the ratio would stay fixed. So if I use this point over here, okay, the y coordinates over the radius would be 2 over 4. And if I use this point over here, the y coordinate over the radius would be 100 over 200. In each case, sine 30 simplifies to a half. So sine is just the name of something. What's the name of? It's the name of the ratio of the y coordinate over radius for a particular angle. Okay, if the angle changes, so for instance, if we moved up here, it became bigger than 30 degrees, less than 90, then what the y coordinate get bigger, but the ratio for that new angle, like say sine of 60, would be root 3 over 2. Anywhere along 60 degrees, you'd get the same ratio. Right, so that would be sine. So if I looked at cos of 30 degrees, well, people observe that it's obvious, well, it's quite obvious that the ratio of the x coordinate over the radius will stay fixed for 30 degrees. So again, it doesn't matter which point you use. Cos 30 degrees could be equal to root 3, the x coordinate over the radius, which is 2, if I use that point over there. If I use this point over here, it would be 2 root 3, okay, over 4. And if I use this point over here, the x-coordinate would be 100 root 3 over the radius, which is 200. All of those simplify to root 3 over 2. And you can go check on your calculator. Cos of 30, if you enter that in, is equal to root 3 over 2. What's your calculator working out? It's working out the ratio of the y-coordinates over the radius for 30 degrees. Is that not very fascinating, Madam Violin?
Oh, yes.
Lovely, lovely stuff. I know.
Great.
Aren't you lucky to be benefiting from this? Right.
Love it.
So then, that's cos of 30 degrees. Home learning. It's the way to go. Right.
Are you writing neatly?
I'm trying to write neatly. It's a bit of a dog show right now, though.
Are your pants pulled up?
My pants are pulled up.
Good.
Okay. Right. So now, if I if I look at tan of 30 degrees, okay, well, tan is just given the name given to the ratio, okay, of the y-coordinate over the x-coordinate, which would be equal to 1 over root 3 if I use that point, 2 over 4 if I use this point over here, and 100, well, I think absolute rubbish. Tan of 30 would be y over x, which would be 2 over 2 root 3 over there. And if I use this point, it would be, the y value would be 100 over 100 root 3, which all simplifies to 1 over root 3. However, if you enter tan 30 into your calculator, it gives you a different answer. It will give you, well, what your calculator does is it rationalizes the denominator by timesing the top and the bottom by root 3. And so it'll become root 3 over 3. So your calculator will spit out root 3 over 3, but I promise you it's the same thing as that. Right, so the key idea, what is trig? It's just a study of ratios, using the fact that the ratio stays fixed, okay, for if the angle stays fixed, right? So, and it doesn't matter where that angle is. I could have an angle that goes like this, okay? If I could have angle beta over there, then the ratios anywhere along this line for that angle beta, okay, for y over r, y over x, and x over r would all stay fixed. That's all trig is. Right, and from that all kinds of other delicious maths develop. So in general, when we're working on a Cartesian plane, remember that your angle is measured in an anti-clockwise direction. Okay, the distance to the point is called the radius. Okay, and there's the x and the y coordinates. Okay, positive angles anti-clockwise, and negative angles clockwise. So in general, sine theta is equal to the ratio of the y-coordinate over the radius. Cos is the name given to the ratio of the x-coordinate over the radius for that angle. And tan theta is the relationship of the y-coordinate over the x-coordinate for that particular angle. It's meaningless just to talk about sine, cos, or tan. It has to be sine of an angle, cos of an angle, or tan of an angle. And the little stupid rhyme you can remember, okay, because this you've got to know in your sleep, okay, and you can say shade your rear, so sine is equal to y over r, shade your rear. You can think of somebody, whoever you like, shading their rear, shade your rear, cos x rays tan your exterior. Here's a look of shock from the music department. Okay, shade, the word rear is being mentioned live on a math lesson. Shade your rear, because x rays tan your exterior. And that is a little, what do you call that kind of thing? Limerick or something, load of rubbish that you can use to remember those. These
musicians keep it clean.
You must
Father
use
Charles goes down,
in your
ends
sleep.
battle.
Sorry about the peanut gallery. Okay, right. So get that all down. Hopefully it makes some sense. Alex, to apologize for my writing. Okay. So the peanut gallery is once again criticizing my handwriting. Little does she know that this for me is incredible. Right. So we've got an angle theta on the Cartesian plane. Okay, the radius is equal to root 5. Your x-coordinate is 2, your y-coordinate is a. The question is solve for a, and hence determine cos theta, tan theta, and sine theta. Right, off you go. Right, so now you've given it a try. And the first thing you're going to say is, right, to solve for A, well, your fundamental principle is that on the Cartesian plane, an x-coordinate squared plus a y-coordinate squared is always equal to your radius squared. Okay, if you're working with a fixed radius, that's the equation for a circle center origin. So that's where our starting point is always going to be. So your x squared coordinate in this case is 2 squared plus a squared is going to be equal to root 5 squared. Okay, so I'm going to get 4 plus a squared is equal to 5. So a squared is 5 minus 4, which is 1. So a, don't forget, could be plus or negative 1, which is really why we're always going to need a diagram in these kinds of questions. Because the diagram, it's only from the diagram that you can see that in fact a is a y-coordinate, and at this point over here, your y-coordinate must be negative. So a, in fact, must be equal to negative 1, and you could only see that because you've got your diagram. And when we do Pythagoras questions, that's why it's so important to figure out which quadrant we're working in order to see whether the sign of the variable is going to be positive or negative. Right, so now we've got a is equal to negative 1. So for this angle theta, you can always do a little summary. What do we know? We know that if x is 2, the y value that goes with it is negative 1, that's a, and the radius is equal to root 5. Okay, if x is 2, y is negative 1. We've figured out that this was negative 1. Okay, and now we can go figure out, once we've got all 3 variables, we can figure out the trig ratio. So now it's just using a definition. Show shade your rear, because x raised, so cos is equal to the x coordinate over the radius, which is going to be equal to 2 over root 5. Okay, you can leave it with an irrational denominator in Matric. Okay, 2 over root 5. Tan is equal to y over x, okay, which is going to be equal to negative 1 over 2. And sine is going to be equal to y over r, which is going to be equal to, the y coordinate is 2, and when that happens, the radius that goes with it is root 5. Okay? Right. Okay.
Right.
Lovely. Right.
Right.
So many of you can answer that question, in which quadrants the trig functions are positive. So the question is, in which quadrants are the trig functions positive? Okay, so our quadrants, quadrant 1, 2, 3, and 4. And a lot of you can answer that question pretty easily, but if I asked you, because you just say, cast diagram. Okay, but if I asked you why, I hope you'll be able to explain it as well. And the explanation is really simple. If I was working in quadrant 1, any point in quadrant 1, well, the x-coordinate is positive, and the y-coordinate is positive. Okay, in quadrant 2, the x-coordinate is negative, and the y-coordinate is still positive. I've gone to the left, and I've gone up. In quadrant 3, I've gone to the left, so my x-coordinate is negative, and my y-coordinate is also negative. And in quadrant 4, I've gone to the right, so my x-coordinate is positive, and my y-coordinate is negative. And in all cases, well, your radius is a distance, so your radius is always positive. Right. And from that, and using our definitions, that sine is the y-coordinate of the radius, cos is the x-coordinate of the radius, and tan is the y-coordinate over the x-coordinate, then it's pretty obvious where things are positive. So, in quadrant 1, what's going to be positive? Well, everything's positive. Okay, x, y, and r are all positive. So in quadrant 1, all of your trig functions are positive. Okay, and in quadrant 2, well, cos is going to be positive over positive, x over r. Tan is going to be, absolute drivel. Okay, if I look at sine, sine is going to be the y-coordinate over the radius, which will be positive over positive. So sine is going to be positive. Cos, however, will be x over r, which is negative over positive, which is negative. And tan will be y, which is positive, over x, which is negative, which will also be negative. So in quadrant 2, the only trig function that's positive is sine. Okay? And in quadrant 3, well, sine will be the y-coordinate over the radius, which is negative over positive, which is negative. Cos will be x coordinate over the radius at this point will be negative over positive, which is negative. However, tan will be a negative divided by a negative, and Madam Violin, a negative divided by a negative is a
Positive.
fantastic. Right, so tan, okay, is going to be positive in quadrant 3, and in quadrant 4, okay, sine will be negative over positive, which is negative. Cos will be positive over positive, which is positive. So cos is going to be positive, and tan y over x, negative over positive, is negative. So this is where we get our little summary from, that the cast diagram, some of you like to call it, okay, and we're going to use it a lot. What is it? The main thing is a lot of you know that, but what does it tell you? It tells you whether trig functions are positive. Okay, so you can remember cast, you can remember all students talk crap, you can remember all students take cocaine, okay, and I'm sure there are a million of other ones, some of which probably can't be mentioned on a family channel. Right, that is a really important summary. Good times. Right, welcome back. Okay, so the next thing we're going to move on to, it leads us to Pythagoras type questions on the Cartesian planes, okay, for whatever reason they call that. And the key thing to look out for in the question is it often says, without using a calculator, or by showing all working, or by making use of a diagram, go evaluate something. And if it's not special angles, then it's normally this type of question. And fundamentally, there are three main steps. Okay, what you have to do is use all the given info. Okay, you usually give them 2 bits of information. Okay, and use those given information to figure out which quadrant you're working in. That's really important. Okay, then solve for the missing variable using the fact that x squared plus y squared is r squared. And then you can only start looking at answering the darn question. Okay, so hopefully you remember these. Okay, so the first example I want you to try on your own. It says, by using a diagram and without a calculator, given 5 tan theta minus 12 is equal to 0, and cos theta is less than 0, evaluate sine theta and cos theta. Right, give that a go. So hopefully you've tried this question and you've managed. If you haven't, here's the solution. Okay, so you're given 2 bits of information. You're told that 5 tan theta minus 12 is 0, and cos theta is less than 0. Okay, so first thing, go isolate the trig function. So in this case, it will become tan theta is equal to 12 over 5, which means that tan for this particular angle is positive. So if I go use all students talk crap, where is tan positive? In quadrant 1 and in quadrant 3. So I go tick off 1 bit of information. So first of all, tan is positive there, and tan is positive there, right? So I've used that bit of information, but they give us another information about angle theta. They tell you cos of this angle theta is negative. Well, cos is positive there and there, so where's it negative? In quadrant 2 and 3, so I'll go mark that with a cross. And where I get a tick and a cross, that's the quadrant I must be working in. Okay, and that's a really important step. So to draw a diagram, put a point in quadrant 3, join it to the center. So this over here must be your angle theta. Okay, right. Then fill in what we're given. Well, we're told that tan theta is equal to 12 over 5. And the definition of tan, shade your rear because x-ray tan your exterior. So your y coordinate is 12 and your x coordinate is 5. But that should make you anxious. Why? Because if I look at my diagram, the x coordinate must be negative, it's gone to the left at this point, and the y coordinate must be negative. But how come this is still fine? Well, in fact then, tan in this particular case is negative 12 over negative 5. So your y value is negative 12 and your x value is negative 5. And that's why the diagram is important. To know which quadrant you're going to be in. Why do you want to know which quadrant you're going to be in? So whether the x and the y coordinates are positive or negative. Right, fantastic stuff. So x is negative 5 and y is equal to negative 12. Okay, and without the diagram you wouldn't know that. We still, however, have to go find r. So what links up x, y, and r? R squared is equal to x squared plus y squared. So r squared is going to be equal to negative 5 squared plus negative 12 squared, which is going to be 169. And if it was just algebra, you'd say r is plus minus 13, but we know that the radius has to be positive, so your radius is equal to 13. But you should know that Pythagorean triple, you don't have to show any working, you could just write down. If you recognize that in a right angle triangle, if x is, the one side is 5, the other short side is 12, then the hypotenuse will be 13, you could just write down the answer. So now what I always do is I do a little summary for that angle. So in this case, for angle of theta, x is equal to negative 5, y is equal to negative 12, and r is equal to 13. And once you've got all three bits of information, then you can answer the question. So that was your last step. Go answer the darn question. And the question was, go figure out sine theta. Well, sine theta by definition is the y-coordinate over the radius, which will be negative 12 over 13. And then it said go evaluate cos theta. So cos theta is equal to the x-coordinate over the radius, which will be negative 5 over 13. Okay, I hope that makes sense. Good people. And I hope you got it right. Right, try this one on your own. Given alpha is an element of 90 degrees to 70, and sine alpha is equal to a negative a half, evaluate by using a diagram root 3 tan theta plus cos theta. Okay, so give that a try on your own. What's your steps? Use the two bits of information given. Sine is negative, and your angle lies between 90 and 270. So go use those bits of information to figure out which quadrant that you're in. Find your missing variable using x squared plus y squared is r squared, and then you can engage with the actual question. Right, give that a go. Okay, so if I do this question, first of all, I have that sine is negative. So where is sine positive? Sine is positive in 1 and 2, so sine is negative in that quadrant and that quadrant. So that's that bit of information used. And then you're told that the angle lies between 90 and 270. Well, here's 90, here's 270, so it's between there and there, so it's in this quadrant, in that quadrant, and once again, just by coincidence, we're in quadrant 3. So what I do, I put a point in quadrant 3 in order to draw my diagram. Okay. Here is angle alpha, going in an anti-clockwise direction. What do I know? Well, I know sine is equal to the y-coordinate over the radius, so the y-coordinate must be negative 1, and the radius is equal to 2. Okay, so now what you have to do, go find your missing variable using the fact that x squared plus y squared is equal to r squared. So in other words, x squared plus negative 1 squared is equal to 2 squared. So x squared is going to be equal to 4 minus 1, which is 3. So x is equal to plus or minus the square root of 3. And this is why I need the diagram. Because if you look at the diagram, what's the x-coordinate have to be? The x-coordinate has to be negative. So x is equal to negative root 3. So now I can do my little summary for this angle. So for angle alpha, when x is equal to negative root 3, y is equal to negative 1, and r is equal to 2. Okay, so once I've got all three of those values, I can go answer the question. The question is go work out root 3 tan theta plus cos theta. So it'll be equal to root 3, which is root 3 over 1. Tan is y over x, which will be negative 1 over negative root 3. Okay, plus cos theta, which is going to be x, which is negative root 3. Okay, over r, which is 2. Okay, and if I simplify that, root 3's will cancel, the sign overall will be positive, okay, because a negative and a negative cancel. Okay, so I end up with 1 minus root 3 over 2. You want to make it simplified, it will be 2 minus root 3 over 2. Always leave things in third form. Okay, right. So that is your answer. Isn't that amazing, ma'am?
Amazing.
Thank you. Get that down. Right, the next one we're moving on to is reduction formula. And normally you recognize that kind of question because it says go express as a function of theta, and they're given as 180 sine 180 minus theta, so whatever, sine 360 plus theta, and you've got to just get it to sine theta or cos theta or whatever it is. now what creates confusion, this logic, when we're using this method that we're kind of going to be using now, we kind of assume that every angle is an acute angle. However, it doesn't have to be. Okay, the logic will still work, the rules will still work, even if theta was an acute angle. It's just this thing of assuming theta is an acute angle. It's just a way of remembering things and doing the sum. So it's easier if you consider theta as an acute angle, and that's just for kind of remembering things. However, theta can in fact be any size, not cis. Okay, and the logic still works. Okay, so all these rules we're going to use. Okay, theta could be in fact any size angle, but the way we remember it is just to consider theta as an acute angle. Isn't that amazing?
I'm tired already.
Oh no, right. So this diagram is really important on the Cartesian plane, 0, 90, 180, 270, 360. So when I talk about 90 minus, what does that mean? Well, a positive angle is in that direction. So I've gone 90 and I've gone back. So there's 90 minus. Okay, and I've gone back just a little bit like an acute angle. Then I've gone to 90 and a bit more. So 90 plus would be in quadrant 2. 90 minus would be in quadrant 1. Quadrant 1, 2, 3, and 4. Okay, so if I went to 180 minus, it means 180 and I've gone back a little bit. That's why I think of it as being acute. Okay, I'm in quadrant 2. So anything in quadrant 2, sign would be positive, everything else would be negative. If I went 180 plus, I'd be in quadrant 3. Okay, and the only thing that would be positive would be tan. If I went, we don't have to work with 270 in core for some reason. If I go 360 and back a bit, okay, I end up in quadrant 4, and the only thing that's positive in quadrant 4 is cos. If I go 360 and then a little bit more, okay, I'm in quadrant 1, okay, and all of your trig functions will be positive. Okay, and there are two types of reduction formula that we look at. One is where we bounce off the x-axis, so whether it's 180 minus or 180 plus or any kind of variation of that, and 360 plus, 360 minus, and then all you have to simply do is check if it's positive or negative and go do your reduction. Okay, so that is your key idea, and remember, if theta is acute, it's just an easy way of remembering it. It doesn't have to be acute. Okay, so get that down, and we're going to do a couple of little type 1 examples. I just want you to try this basic stuff on your own quickly, just make 100% sure you're confident with that. So I want you to go do those 6 sums by yourself using that logic. Okay, remember they're all type 1, you're bouncing off the x-axis, so you've got to just figure out which quadrant you're in and if you're going to be positive or negative. So go reduce to functions of theta, sine 180 plus theta, tan 180 plus theta, okay, cos 360 minus theta, sine 360 minus theta, sine 180 minus theta, and tan 180 minus theta. Right, give those 6 a go. Right, so all you simply do, sine 180 plus theta, where am I? That's for me the most important part of it, figure out where you are on the Cartesian plane. So 180 plus, okay, you're in quadrant 3. What happens to sine in quadrant 3? Here's 180 plus, I'm sitting over here. Okay, in quadrant 3, sine is negative, so you're simply going to reduce it, put the negative in front, negative sine theta. Right, then tan 180 plus, once again, we're in quadrant 3. What happens to tan in quadrant 3? It's positive, so it's just going to be tan theta. Right, then 360 minus means I've gone to 360 and I've gone back a bit, so I'm sitting in quadrant 4. What happens to cos in quadrant 4? It's positive, so it's just going to be cos theta. Sine 360 minus theta, again 360 minus, I'm in this quadrant. What happens to sine in that quadrant? It becomes negative, so it's negative sine theta. Sine 180 minus theta, 180 I've gone back a bit, now I'm in quadrant 2. What happens to sine in that quadrant? It's positive. Okay, so it's just going to reduce to sine theta, and tan 180 minus theta, I've gone there and I've gone back, so it's going to be simply equal to, tan is negative in quadrant 2, so it's going to be negative tan theta. Okay, right, so there are your solutions, and that's your basic stuff. It's pretty easy marks if you just remember how to go about it. Okay, now type 2 of reduction formula is when you, the language I use is you bounce off the y-axis. So the questions are 90 degrees plus or minus theta. And your steps is just one extra step. Okay, first of all you check if it's going to be positive or negative. So you figure out where you are, and then based on that you check, is it going to be positive or negative in that quadrant? But it's according to the original name. Okay, not to the function it's going to change to. And then remember for 90, sine and cos interchange. Okay, But whether it's positive or negative depends on the original name of the function. Right, so go try to do these four sums, expressed as a function of theta, sine 90 minus theta, sine 90 plus theta, cos 90 plus theta, cos 90 minus theta. Right, give those a go. Right, so for sine 90 minus theta, where am I? First of all, always find out where the hell you are. Okay, do we know where we are? Yes, we are. We're in quadrant 1, 90 minus. In quadrant 1, all of the trig functions are positive, so it's going to be positive. But if it's 90, there's a name change, and sine and cos interchange. Right, for next one, sine 90 plus theta. Well, where am I? I've gone to 90 and a little bit more. I'm in quadrant 2. What happens to sine in quadrant 2? You look at the original name. In quadrant 2, sine is positive, but then there's a 90 alarm bells, ding, 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 must go off because there's going to be a name change whenever you see 90. Okay. Cos 90 plus theta, or where the hell am I? Okay, 90 plus, I'm in quadrant 2. What happens to the original name? What happens to cos in quadrant 2? Cos in quadrant 2 is negative, and then it changes name to its cofunction, which is negative sine theta. Cos 90 minus, where am I? I'm in quadrant 1. What happens to cos in quadrant 1? It's positive. Okay, but it's a 90, ding ding, must change names to sine theta. A quick explanation of negative angles. Again, we're assuming that theta is acute, just as a way of helping to solve. Theta doesn't have to be acute though. So if I took an angle theta, and I had a radius of r, and then I went in the opposite direction, so it was negative theta, and I kept a radius of r, then if that was a and b, well, the x-coordinate there would be the same, that would be a, and the y-coordinate there would be negative b. The sine of negative b, negative theta, would be the ratio of y over r, which would be negative b over r, okay? And sine of theta, though, would be b over r. So in general, they've got the opposite signs. Okay, so sine of negative an angle would be negative sine of the angle. However, if I took cos of negative theta, well, cos of negative theta would be x over r, which would be a over r, and cos of theta would also be a over r. So that's why, in general, cos of a negative angle is the same thing as cos of an angle, and tan of negative theta would be y over x, which would be negative b over r. However, tan of theta would be equal to y over x, which would be b over r. Okay, and tan of negative theta would then be negative tan theta. So the only trig function that stays positive when you're expressing a negative angle as a positive angle is cos. Everything else has a negative in front of it. And the way you can remember it is that for a negative angle behaves as if it was, if I'm assuming that's acute, it's just a way of remembering, it doesn't have to be acute. Okay, cos is positive in quadrant 4. Okay, so that's a way you can remember this identity, that reduction over there. Okay, and again, if the angles were to show you obtuse, so say you had alpha over there and negative alpha over there, the same logic would apply. If that x value was a and that was b, then this x value would be the same, a, and b would be negative b. The x values would be the same, the y coordinates would be different. So once again, cos of alpha would be x over r, which would be a over r, and cos of negative alpha would also be a over r. Okay, so and that would be the only one where cos of the negative angle and the positive angle ratio are the same. Okay. Right, and then just some unusual reductions, and the basic principle is going to be this. I don't go take out a negative and do all a million steps that all the textbooks do. First of all I do is I figure out where you are on the Cartesian plane. And to do that, you always assume theta is an acute angle. Okay. So, but again, that's just to help us make life easier. Okay, it will work for any size angle. Just figure out where you are on the Cartesian plane. Once you've done that, then say to yourself, okay, in that quadrant, is the trig function going to be positive or negative? So is your trig function positive or negative in that quadrant? Okay, right. And then if it's a question that's bouncing off the y-axis, so if it's 90 plus or minus, your name is going to change. Sine and cos are going to interchange. We'll never give you one with tan. Okay. And if it's 180 plus or minus or 360 plus or minus, the name will stay the same. So I'm just going to show you a couple of those ones. Okay, we're nearly there. Get that down. Good day, good day. It's a long video, I know. Okay, right. Expressed as a function of theta. So these are what I mean by the strange ones that we're talking about. And if you've got minus theta minus 180, so this is not the normal time. So I just first of all figure out where I am. So what I do is I do something like this. I say, right, negative theta, now I'm over here. Okay, if I've gone through negative theta, it means I've gone a little bit in that direction. Always treat theta as acute. Now what have I got to do? I've got to keep going in that direction because it's negative for another 180 degrees. So it's minus theta, okay, and then minus another 180 degrees. So where do I end up? Okay, and you should be able to do that in your head, but you don't have to, in quadrant 2. So I go minus theta minus another 180 means I'm working in quadrant 2. And then all I say is, if I'm in quadrant 2, what happens to sine? And sine stays positive. Is there a 180 or a 90 or whatever thing on there? It's a 180, so there's going to be no name change. So you're going to end up with an answer of positive sine theta. You don't have to show any working. You can go straight to the answer. You don't have to go take out a negative and do all that stuff. I find people tend to make careless mistakes. So find out where you are. Is it going to be positive or negative in that quadrant? Right, then tan theta minus 180. Well, first of all, I've got to travel through an angle of theta in a positive direction. So now I'm sitting over here. Now what I have to do, I have to minus 180, which means I've got to go back through negative 180 degrees. In other words, negative angle is in a clockwise direction. So I've traveled through theta, anti-clockwise, 180 degrees, clockwise, which leaves me in this quadrant over here. I'm in quadrant 3. In quadrant 3, what happens to tan? Questions about tan. Tan stays positive, so it's going to be positive. There's no 90, so that's just going to be tan of, it's going to reduce to tan theta. Again, you don't have to show any working. Right, and the last one, cos of theta minus 90. Well, again, find out where the hell you are. So I've gone through theta, which is over there. Now I go in a negative direction through 90. So there's negative 90. Where am I? Okay, I'm in quadrant 4. Look at the original name. What happens to cos in quadrant 4? It's positive. But now there's a 90, ding, ding, ding. Alarm bells must go off. Okay, so now cos is then going to change to its co-function, which is sine. So your answer is going to be positive sine theta. Right, nearly there. Right, just one other thing, reductions for angles bigger than 360 degrees. Well, all I do is I just work on the Cartesian plane once again. So I go 90, 180, 270, 360. If I keep going, plus 90 is 450, plus 90, 540, 630, 720, and you can keep going on like that. Okay, so once again, what I simply do, I figure out where the hell am I? Is it positive or negative? Then if it's bounced off the y-axis, in other words, it's 9, okay, if it's bounced off the y-axis, there's going to be a name change. If it bounced off the x-axis, there isn't going to be a name change. So, sine 720 minus theta. Well, where am I? Well, I've gone round 360, 720, I get there and I bounce back a bit. So 720 minus is going to take me to that quadrant. Okay, what happens to sine in that quadrant? Well, if I'm using cost, sine is going to be, in this quadrant, we're using all students talk crap. In this quadrant, sine is negative, so it's going to be negative, and I bounced off the x-axis, so there's no name change. So y-axis, that's dangerous, so it's going to be simply negative sine theta. Right, then cos 450 plus theta, okay, 450 plus, okay, I'm in that quadrant, where am I? 360, I've gone all the way around, okay, I've gone all the way around to 450, so I've gone 360 and a bit more, and then I've gone on a bit. Okay, so 450 plus takes me into that quadrant over there. Okay, what happens to cos? Look at the original name. Cos in that quadrant is going to be negative, but 450 is bouncing off the y-axis, so there's going to be a name change, so that's going to be negative sine theta. Right, and then last one, tan of 540 plus theta. Okay, well 540 okay, means, what have I done? Well, to get to 540, I've gone 360, 450, 540, and then I've gone on a bit. Okay, so there's 540 plus theta, so I'm in quadrant 3. Okay, what happens to tan in that quadrant? Tan stays positive. It's bounced off the x-axis. That's good news. No name change. So it's just going to be positive tan theta. Hope that makes sense.
Day, students.
Right, your next exciting sum. Okay. And this is a typical kind of exam question. You've got sine 180 plus theta, tan negative theta, cos 720 plus theta. Sorry about the noise, there's a violin lesson going on in the background. Sine theta minus 180, sine 90 plus theta, tan minus theta minus 180. This is involving just about all the types that we've used. So, you've got to show each thing, guys. You can't just, you've got to show the sign that goes with each reduction. You can't cancel your signs without showing the marker what you do. So, again, where are we? 180 plus. Where am I? I've gone 180 and a bit more. I'm in this quadrant. What happens to sine in that quadrant? Sine becomes negative. There's one mark. It's Christmas time. Negative sine theta. Next one, tan negative theta. Okay, a negative angle behaves like it's in quadrant 4. Okay, so tan is going to be reduced to, I get everything to functions of theta. Negative tan theta. Tick, tick, happy days. 720 plus. Where's 720? Well, I've gone around this 360. Another 360 is 720. And then I've gone a bit more. So 720 plus is in that quadrant. Everything stays positive there. So it's simply going to be cos theta. Then sine theta minus 180. Theta minus 180. What have I done? Well, I've gone through positive theta. Then I've gone back negative 180. There's theta of minus 180. I'm in this quadrant over here. What happens to sine in that quadrant? Positive or negative?
Negative.
Yes, well done. Okay, sine is going to be negative in that quadrant. So it's going to be negative sine theta. That's that bit over there. This bit over here. Sine 90 plus theta. Okay, well, I've gone to 90 and I've gone a bit more. Okay, so I'm in quadrant 2. What happens to sine? The original name in quadrant 2, sine is going to be positive, but it's going to change name to cos theta. And last one, minus theta minus 180. Well, minus theta, I'm over here. If I minus another 180, I end up over here. Tan of minus, so I'm in quadrant 2. What happens to tan there? It becomes negative. So it's negative tan theta. Everything's times, so I can cancel. So negative tan theta is going to cancel with negative tan theta. Cos theta with cos theta. Negative sine theta with negative sine theta. And voila, the answer is 1. Before I get kicked out the lounge to make way for some TV, okay, I want you to try and do exercise 4.1, mind-blown math, and just do for today, question A, B, and C. Right. Thanks a lot. Have a tremendous day. Take care. Arrivederci.